Hello class, this is a video tutorial on trigonometric functions and graphing. In this video we'll be looking straight away into three examples of graphing sine, cosine, and tan. So when it comes to graphing trig functions, we should understand very well what the original function looks like, as well as the amplitude, period, and mean. So going over this very quickly. Amplitude meaning the highest and lowest it'll go from the mean value. The mean value is the line at which the function cycles up and down along. And the period means how long it takes for the cycle to finish. So one cycle of sine goes up and down once. So that cycle of up and down once will finish in 2 pi. Okay, we'll get into some more examples now. Here we go. The first thing we should look at is the easiest point, is the mean value. This plus 1, or if you watch the previous video, plus k. So the mean value now is going to be, there's going to be a line, y is equal to 1. So what that means is there's going to be a horizontal line, y equals 1, that the function cycles up and down along, like so. There we go. Now let's take a look at the amplitude. Well, I'd write it down, but because it has an amplitude of 1, the real thing, that the real values that we need to understand is what are the highest and lowest points that y will be. So let's consider this. Because this entire graph has been moved up here, this highest point will be at 2, and this lowest point, moved up 1, will be at 0. So this function cycles in y values from 0 until 2. Okay? And now lastly, we need to look at the period, p. And to calculate the period, we take 2 pi and we divide it by the value in front, the coefficient of x in the function, so 2, meaning the period is going to be pi. What this means is that the function will finish the cycle up and down once at pi and repeat itself again along the next distance of pi. Okay, so here we go. Plotting all the critical points. So let's plot this first point here in black. That point will now be at 1. Let's plot this next point. This highest point of pi on 2. Well, it's going to be moved up. Whoops, daisy. It's going to be moved up. And its distance is going to be halved because of this dilation or contraction of 2. So if this is a distance of pi on 2, we're going to halve that. So pi on 2 is now going to be pi on 4. There we go. Let's plot the next point. The next critical point here is this intersect. Well, that's going to be moved up along here, and its distance, well, it's a distance of pi, that's going to halve, so pi on 2 is where it's going to intersect. So already we have a graph that's forming. Whoops, graph this a little bit more neatly. Graph more neatly, like so. We are halfway there before the cycle will continue. The next critical point we need to graph is this lowest point here. So the lowest point now is going to be at 0. Okay, now this distance of 3 pi on 2 is going to be halved. It's going to be 3 pi on 4. So the lowest point here is going to be at 3 pi on 4. And then lastly, delete some of this clutter. Then lastly, 2 pi is going to be shifted up because of the mean value, and its distance from 0, being 2 pi, will be halved to just be pi. So it's going to be here. That is one cycle between 0 and pi. Now this cycle will repeat itself. Oops, let's draw this very neatly until 2 pi. There we go. And also, because we want to go as low as negative pi, this the function, will mirror itself along its mean value and the y-axis. Oops. Yep. There we go. So this is only a sketch, but I hope that gave you an insight into graphing sine of 2x plus 1. And I hope you can take on your knowledge from this to different graphs of sine of x. Hope to see you in the next video. Best of luck.